this video, we're going to talk about 4.6, which is the rank of and systems of linear equations, but mostly the rank of a matrix is what we're going to talk about. So we're going to start with number 3, and it is the matrix 4, 3, 1, 1, negative 4, 0, and we're asked to find the row vectors. We'll write those in this notation. And then B asks us to find the column vectors, and we'll write those in this notation. So we put the matrix symbol around our column vectors, but we just use our parentheses around our row vectors for this section. Right, number 5 asks us to do the same. Right, 5 asks us to find the basis for the row space and rank. So A, find a basis for the row space, and B, the rank of the matrix. So when we have 5 is 1, 0, 0, 2. Since that's a square matrix, we can RREF that to turn it into 1, 0, 0, 1. And then we can look at our column vectors here, and A is 1, 0, 0, 1. I'm sorry, our row vectors. What did I say? Column vectors. 1, 0, 0, 1, because this is our row space. And so that is A. And then the number of vectors that are in that row space there is 2, so that's our rank. Let's look at number 7. And it is 1, negative 3, 2, 4, 2, 1. When I RREF that, then we get 1, 0, 1 half, 0, 1, negative 1 half. So my basis for the row space is 1, 0, 1 half, comma, 0, 1, negative 1 half. And there are 2 vectors in that basis for my row space, so the rank is 2. Let's look at number 11. And we have negative 2, negative 4, 4, 5, 3, 6, negative 6, negative 4, negative 2, negative 4, 4, 9. And when I RREF that, I get 1, 1, 0. Sorry, 1, 2, negative 2, 0, 0, 0, 0, 1, 0, 0, 0, 0. So I'm not interested in the row of zeros for my basis. I only want the rows that are non-zero. So 1, 2, negative 2, 0, comma, 0, 0, 0, 1. And that gives me a rank of 2. There's one row of zeros, which will give me something called a nullity of 1. And so 2 plus 1, there's 3 rows total. All right. 15. We have finding the basis for a subspace of R3. Clear this out. Give myself some space for this. S equals, and then I don't know why the hardest of these problems is first, but it is. So we have 4, 4, 8, 1, 1, 2, 1, 1, 1. That we set up those row vectors there. We're going to RREF that, and we get 1, 1, 0, 0, 0, 1, 0, 0, 0. So that gives me my basis that I'm going to call capital B. I haven't used that notation yet, but that's a pretty common notation going forward here. So 1, 1, 0, 0, 0, 1. And then we have number 17 says that we want to find the basis of a subspace. This is for R4. So S is equal to, and we have 4 4x4 or 4 4-dimensional vectors. Three, -8, 17, and 0, -3, 0, 15. So we're going to have a basis here if we would 253, 3, 2, 3, -2, 8, -3, -8, 17, 0, -3, 0, 15. If I would RREF that, I'd get my get 1, 0, -1, 0, 0, 1, 0, 0. I'd get 0, 0, 0, 1. Then I'd get a row of zeros down here. So my basis B is 0, -1, 0, 0, 1, 0, 0, 0, 0, 0, 1. $19 says that S is equal to -3, 2, 5, 28, and then -6, 1, -8, -1. and then 14, negative 10, 12, negative 10, and 0, 5, 12, and 50. So this is 3, 2, 5, 28, negative 6, 1, negative 8, negative 1, 14, negative 10, 12, negative 10, and 0, 5, 12, 50. Going to RREF that. We get 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, which is called our standard basis. Here we have ones along the diagonal, zeros everywhere else. So our B is 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. At number 23, it says that we're starting off with 1, 2, 4, negative 1, 2, 1. When I RREF that, I get, so 23 is asking me to do something a little different here. It's asking me for a basis of the column space and the rank of the matrix. So one of the ways that I can find the basis for the column space is what I'm doing right now. 1, 0, 3/2, 0, 1, 5/4. Now look at these column vectors here that have ones in the positions where they should here, but I'm going to ignore the ones that don't. So I see that my basis here is column vector 1, 0, and the column vector 0, 1, and that gives me a rank here of 2. Makes sense because I should have the same rank whether I'm looking at the row space or column space, and I have 2 row vectors here, so I should have 2 column vectors here. If that process didn't make sense to you as to why I did it that way because your teacher did something else, don't worry, I'll do most of the problems here the other way. So let's look at number 25. We have 25 is starting off with 2, 4, negative 3, negative 6, 7, 14, negative 6, negative 3, negative 2, negative 4, 1, negative 2, and 2, 4, negative 2, negative 2. So if I can take the transpose of this matrix and make my columns my rows and my rows my columns, then I can find the row space of the transform, and that should be my column space of my original. So I'm going to transpose this and get 2, 7, negative 2, 2, 4, 14, -4, 4, -3, -6, 1, -2, -6, -3, -2, -2. I'm going to RREF that, and that gives me 1, 0, 5 ninths, 2 ninths, 0, 1, -4 ninths, 2 ninths, and 0, 0, 0, 0, and 0, 0, 0, 0. So turning these row vectors into column vectors here. For part A, my basis is going to be 1, 0, 1, 0, 5 ninths, 2 ninths, and 0, 1, -4 ninths, 2 ninths. That gives me a rank of 2. And let's go ahead here with number 29. 29 asks me to find the null space for the matrix, which I kind of already talked about I didn't really talk about the null space. I talked about the nullity, but not the null space. 29 isn't really a great problem for this. It's 1, 2, 3. It's just one row, and I'm interested in the equation here, x1 plus 2x2 plus 3x3 is equal to 0. And then I'm going to solve for x1 here. I always solve for my lowest indexed like this. And then I want to, personally, I know this isn't what the book does, but I want to take the lowest indexed x value here and make it t, and make the next one s. Sometimes the book does that, sometimes it doesn't. So I use t before I use s as a parameter. So that means that x2 is equal to t, x3 is equal to s, and x1 is equal to -2t minus 3s. Like that. So that means that I can write this x1, x2, x3 as -2t minus 3s. Ts, I want to separate that into a part that is t's. So that's -2, 1, and 0, following my coefficients of So I'm going to write it out more explicitly like that. So you can see where there's 0 coefficient of t here, 0 coefficient of s there. And that's going to give me -3, 0, 1 here for my s. And that gives me a null space, the set of t, -2, 1, 0, plus s, -3, 0, 1. All right. Let's go ahead and do number 35 next. 35 says it's the same thing. Yes, I want to find the null space of 35. So A equals to 5, 2, 3, -1, 2, 1. So I'm going to set up the equation. Ax equals 0, where x is a variable matrix here. So that is 5, 2, 3, -1, 2, 1, x1, x2, x3. Sorry, x1, x2. There's only 2 columns here, equals 0. So that sets up the equation. 5x1 plus 2x2 needs to be equal to 0. This is the 0 matrix. This is 0, 0, 0 on this side. 3x1 minus x2 equals 0, and 2x1 plus x2 equals 0. So I'm going to pick these two equations first, since the x2's eliminate, and that gives me 5x1 equals 0, giving me x1 equals 0. If x1 is 0, then x2 has to be 0 here, and so that gives me a 0, 0. There's no parameters for this. It's specifically just 0, 0 was number 35. Let's finish up with number 37 here, which is another problem that asks us to find the null space of a matrix. And it is A equals, this is 1, 3, -2, 4, 0, 1, -1, 2, and -2, 6, 4, -8. So I'm going to RREF this just to make my life easier. Why can I RREF it without setting everything equal to 0? Because the zeros on the right hand side don't change at all. Any constant multiple of 0 is still 0. Adding it to 0 is 0. So it's sufficient to just RREF this matrix here. And that is 1, 0, 1, -2, 0, 1, -1, 2, 0, 0, 0, 0. So that tells me that I have the equation x1 plus x3 minus 2x4 equals to 0. And I have the equation x2 minus x3 plus 2x4 equals to 0. I know I'm going to have some parameters here for this. So solving for x1, x1 is equal to -x3 plus 2x4. And I'm going to call that equal to -t plus 2s. I'm saying that x1, x2, x3, x4. x3 is going to be T, and x4 is going to be S, and so that's that one, and then x2, when I solve for it, is going to be x3 minus 2x4 is going to be T minus 2S. So this is negative T plus 2S, and this is T minus 2S. So that gives me T times, and go and I look at this, negative 1, 1, 1, 0, 1, 1, 0, it's S, and then I have 2, negative 2, 0, 1. If you have your S and T switched, that's okay. They're just parameters there. So, but that's it for this video. We'll come back next time and we will talk about 4.7, which is coordinates and change of basis. So coordinates and change of basis from 4.7 next time. See you for the next video.